Hello, my name is Peter Bellis. I'm working for 2150 Datavault Builder, and in this video we will show you how to solve a use case prepared by the German-speaking Datavault user group. So it's not a demo that we have prepared and has perfect data, but it's really a challenge they have set up and different tool providers, data warehouse automation tools can solve. And in the next 2.5 hours, I will show you how I work on the use case and how I solve it. So you will see all my errors, all my mistakes that I do, and all the problems I have with the data. And you will see the full process from creating the data model, testing the loads, applying the stage data into the data vault core, creating interfaces and creating the reports. Is it a realistic presentation? It is, because I will do really this what I have done, but I need to be honest, my colleague Simon has already prepared this and has checked the data before we started now with this recording. So he talked as well to the people that prepared the use case if he has seen any problems in the data. So we already have answered where we need to fix certain stuff, where we need to work around certain stuff. So we have already an idea how to solve the use case. But I really will build it from scratch. So you will see how long it takes. At the end, we have seen the video will end up somewhere around 2.5 hours. So if it's too long for you, feel free to fast forward, to set the speed to twice the speed. But you can dive into every part. We will add here chapter markers on YouTube that you can jump forward to the different bits. What I will show you today is, first we will start with the data model. We will automatically create all the implementation in real time. That's what the Datavault Builder is about. As well, if we change something in the implementation, it will change the model. I'm not showing this here. Then additionally, we will create a staging area. We will connect to the sources. We have built-in staging modules. We will load the data from a SQL server. For certain data sources, we need to clean up the data because there are some problems with like empty spaces at the end of keys. Then by defining the business keys, we will link the staging area to the vault. We will create interfaces by STD type 2 interfaces and as well STD as of now interfaces. We will add rules, and at the end we will create reports. Everything from the staging layer downstream is ELT, so we are creating this in real time in a database. I'm using here the Snowflake database as an example, but we will support as well all SQL Server variants, Exasol, Oracle, Synapse, dedicated pools, and Postgres as target databases. Source, we support many others. We can connect to Python scripts, NoSQL technologies, or to already staged data if it is already available in the database. The layers that we will cover is infrastructure setup. I did that before we started this video. It took me about 2 minutes to wait. It was one command line command to start up a new environment. Then it downloads the software in the Docker container, start them up, connects to a Snowflake database, and you're good to go, because you don't need to install the software, you just need to start it. It runs on premises, in the cloud, you choose where you run it. What we will see is the model to code conversion. In the live demo, I will not show the changes of code, how it affects the model, but this would work automatically as well. We will see how data profiling works, along documentation, data lineage is created. I will not show you in the demo how we use the REST APIs to implement automated regression testing. I will give you just at the end a short hint how deployment looks like. We have the simplified deployment where you compare two environments and it creates you the deployment script. But I will as well not show you the Git flow based process, which is as well part of the supported ways. You can automate your deployments because you have REST APIs for everything. You can add code versioning in a Git repository. Operations is built in. Master jobs are created automatically. Jobs are created automatically. We will see that how I use that to load data during the design process. And at the end, you could achieve high availability, but that's as well not something I will not show you in this demonstration. So the whole development process is covered, but I will show you only the relevant parts now to solve this use case, modeling, getting the data, linking it to the data warehouse, loading 3 days of or 3 delivers of different data with external timelines. So we use already this external timeline to create the timelines in here. Then we will create interfaces, and at the end we will have Power BI reports. And you will see I'm not too knowledgeable about Power BI, but I don't need to, because if you prepare the data very well here, it's just inserting the data, and the part of the visualization is then the job of the report creator. I'm just using this to verify that I loaded the right data and try to show that we already get the output here. So please enjoy this 2.5 hour ride through the Datavault Builder. So let's go to the Datavault Builder and let's start modeling this. The Datavault Builder is a model-driven data warehouse automation tool. We are starting usually with the business model. We have different modules in it, like the staging area, the vault area where we have persistent staging, raw vault, and business vault. We can create interfaces by creating a dimension model. We can put in business rules. There is a data profiling tool in it. There's data lineage, operations, documentation, and deployment. If you want to see the full presentation of the tool, that's in a separate video. Here in this video, I will show you how we work with the Datavault Builder to solve this use case. So let's start with the order and the order position. So let's assume we're in a meeting with the business users and they tell us about this. So let's add this to our data model. They tell us that there is an order, and this order is grouped into the subject area of sales. Some people refer to this like the data domain. That's everything that we need to capture this kind of concept. This concept is in the background created in real time in the database, and we could define here as order is a sales order. Now let's add the next element, which would be the order line. It already takes sales because I clicked within this data domain. And now let's create a relation. So we ask the business user how many order lines can refer to the same orders. Can the order line refer to many different orders? And they tell us no, many order lines refer to the same order. We could create more than one relation. We will see that a little bit later. So what's the next step? So we have here the position, stored as order line, the order. Now let's add the product. And now we will ask the business user, is the whole order referring to a product or the order line? In our case, it's the order line. And we will see that's then a little bit different when we go to the Webshop. But here for our general data model, we model it like this. And it tells me that I did a mistake, which is correct. That's a user error. I tried to create a second link a second time. I want to link the order line to the product. So that's perfectly fine. Now we see already how our data model is appearing here. Now we need to have as well the customer. This will be grouped in the subject area of the CRM. And we will express that the clients are organized into so-called club partners. I'm using here the Simpson and Witt recommendation to use single R's to describe the concept, but just do it consistently. And you see that we have always a name that is displayed in the visual interface, and this is the name how the stuff will be created in the database. And while we're modeling, this already is happening in the background. So this will be part of the CRM subject area. I selected this already. And now it will be interesting. Now we create a relation from the customer to the club partner. And we say that one customer is representing this club partner. So we select it's a one-to-one relation. So we see the two arrows. So we are here first creating a conceptual model by adding these blue boxes, which represents core business concepts. Then we're adding relations. So we're slowly going down to the logical data model. And a customer belongs to, many customers belongs to a potential club partner, which can be a many to 0 to 1 connection. This is the part that we're modeling here. And the point is we don't need to model everything at once. We could go and step by step start already implementing parts and add stuff later, but this is not a too big model. So just that we have everything in real time together, that you don't need to skip forward and backwards. I do something that I usually wouldn't do. I really create the complete model in here. So I link as well the order to the customer. But it's still that small that we can do this really in one workshop. So many orders to one customer. And then we have the product grouped into categories. Let's add here something like the product category. And the products are organized into product categories. And now we want to do a self-link. That's exactly what we see here in the model, that the product belongs to a category and the category has a parent category. And to know how the relation works exactly, we create here so-called alias, which we will be calling parent product category. So this will not create its own concept. This will be just the alias for the product category itself. This will be expressed by this green line saying it's an identity, that this is the same object by just referenced by a different name. So we can now create a normal relation between the product category and the parent product category. And this means that we have now a hierarchical link, and when we will be creating the output, we can traverse here the circle and flatten it to a path, and we can select how many hierarchies we want to traverse without creating one line of code. Now, something very important is that we will need, and this is described here in the requirements, but it's not in the data model itself, that the two data models from the two systems will be linked by the credit card payment. So we need to add somehow the credit card to this data model. And an order will be paid by a credit card. And a credit card is belonging to a customer. Good. Additionally, a customer has a delivery and a living address. So let's add this as well. And as this is not a one-to-one relation, a customer could have more than one address, at least over time, because that's a historized table and it's a different grain than the customer. We don't just create a satellite, but we will add this object as separate objects. I know there are different opinions on that, if addresses are a thing on its own or not, but I'm not going into this. You can model it as you like it, but that's the way how I'll now model it in this case. I say there are many delivery addresses to one customer. And let's add here as well the address of residence. And you see already while watching this, it's getting very repetitive. Many people will probably just scroll through this section, because as soon as you got the basic things, what are concepts, what are relations, and yes, just what I didn't explain is concepts will turn into hubs, relations will turn into links. Why are we collecting here directed relations? Because it will help us to automate as well the dimensional model later on without redefining anything. So we don't need to then write any SQL script for that. We can just select from the model. So what do we need as next? We need something about logistics, because there are positions that are being delivered, there are delivery services. So let's add this as well. And let's call this logistics. And I assume that one delivery is always executed by one delivery service, but only one service is involved in the delivery. And now the question would be to the business user, can it be that one order is fulfilled by many different delivery services or by many different deliveries? And here, let's have a look at the data model. They tell us that the position is being delivered. So let's add this here. So it could be that one order is fulfilled by multiple deliveries. But this is exactly the point that we are discussing this here. Once we document it, we can test it, and you don't need to think about this kind of relations later. And now there is one special thing. In the deliveries, there is a special object which is called Punctuality. It's not in the data model itself, but it's an important core business concept for this company. It's described here later on in the text that they want to know exactly if they deliver on time or not. So let's add this here already to the model, and let's say we want to know for every order line how it performed. Maybe we need to model it later, but at least we already captured this kind of requirement. So this looks already quite good. Now let's look if we forgot something. We have covered this part here of the deliveries, we have the product categories. So that's already very cool. Now let's have a look on the other source system. There we have the product again. We modeled that already. We have the customer, and we have the club partner, and we have the order. And the order here is the order and the order line denormalized together into one line. But that's fine. We will merge that while loading and map it into our model. So I guess this is the first bit. So we have created a model. The blue boxes are core business concept. These are relations. Here we have hierarchical link. We have here subject areas or data domains, however you want to call them. And we can create here a bookmark to see this arrangement again and again tomorrow. So let's store it under my name, but I share it with my coworkers on the same line. We can now already enter the metadata. And while we were doing so, in the background already the data lineage was prepared. So there's no source data, but it already mapped where it will be. It already started the documentation, so we just can generate now the output. And we see the hub list, and this will be filled and continuously added. But all of this metadata can be accessed at any point in time at the database level. And we could already start deploying this data model to another environment. That's perfectly fine, but for the time being I'm happy, and this would conclude the first part, the model-driven approach. Create assumptions about your business, talk to your business development team or the business owner of the business process owner in this area, and start with the data model. And in the next part we will start staging data, and in the third part we will link the stage data to the data model. Welcome to the Willibald use case. In this video we will do a real-time creation of the use case that was created by the Datavault user group in Germany that will be presented at the DWH conference in Munich. And as we have only 45 minutes there, here in this use case we show you in real time how we have solved the case and how this would work out for you. For sure, we already know the use case, we worked out all the specialties, so it will not be a real world use case in the sense that it's the first time we see everything, but it's everything in real time as we would create it in the Datavault Builder. So how much time does it need as soon as you understand what your sources are, as soon as you have the specification that are written down here in this use case, and how you work in the Datavault Builder. So let's have a look first at the use case. We have a company that is selling seeds, and the seeds are sold in two different ways. The first way is that they sell it online, and they have different partners that are in fact organizations or group of people that are gardening, and they get discounts if they're part of these gardening groups, and this stuff is sold online. The second thing is if Willibald has a little bit stuff on stock they want to get rid of, they do different on-site sales in this gardening organization. So they go on site, they sell there, and they have just a small system capturing what they sold. They are not really capturing the clients, but they're capturing which credit cards they paid with, and they want to now bring together the data and see the overall sales and start analyzing it by product group and many other stuff. And their data model is described in here, and it's in German, but we will still work here in English. We will translate that. I will give you all the English names, but the descriptions at least are available as well in English in the GitHub repository, where you can access all the data model, all the requirements, and as well the data, so you can test it yourself. And what we have here is the main part is we have the order position, we have clients, and these clients are part of these gardening groups, but the gardening group itself is represented as well by one specific client in the system. They live in some places, they have delivery addresses, they get deliveries of these different positions, and for that we have different delivery providers. And here on the top, every position is linked to a product, and the products are linked into categories. And there's a hierarchy of about 3 levels of categories grouped in categories. And the use case itself has as well some data over 3 different deliveries, and the data changes in between. There are some special cases like duplicates, like missing business keys, stuff like that. So it's a very, very nice use case. But we start now with the basic. So let's assume that we're talking now to our business users. So let's go to the Datavault Builder. So after having created the data model, which is step 1, we will go now to more data-driven view and stage the data to connect it with our data models. Let's go to the staging area and let's connect here to a new source system. And we have loaded the data that we see here, that's coming from the Webshop of Willibald, into a SQL Server. These files are here as well provided in the Git repository, so if you want to do this yourself, do the same or similar. And we have loaded the data delivers of 3 different deliveries into 3 different databases, and I will connect now to the first database, and we can connect later to the second and the third to simulate the delivery of 3 different data points in time. And I will call here my source system just as the logical source system, which is the Webshop. I will shorten it here to WS because every object that will be created for the Webshop will contain this kind of ID in it. And it's a SQL Server connector, so let's select that one. And we have here a long list of different connections. You can connect through JDBC to connection to source systems. You can use our Trino connector to connect to NoSQL files like Parquet, Iceberg, or Trino. You can use our gRPC connector to connect to Python scripts. We have stuff like Databricks in there, Google BigQuery, and as well an ELT connector if your data is already staged on the database. Let's take now the SQL Server connector. And let's take the database, which I need to look up how it is named. And it's the Willibald Webshop database. Let's test the connection. And that's it. Now we have connected to the source system. Now we need to select which data we want to stage. And usually if you're coming from classical data warehousing, you would probably try to add all the tables at once. But here we're working in an agile mode. So let's select just the first table, implement it, test the output, and let's go on from there. And we have here the German names. Bestellung is the order, and we have the position, which is the order line. So let's take the order line first. And we see here what the columns are, what the source data type is, and how we will convert it. And it will be converted because I'm using as source a SQL Server, as target a Snowflake database, so it automatically calculates what is necessary to create this kind of stuff. Now I could as well rename columns, and I'm very happy because somebody in the source system already marked the column which will contain the external timeline. So we will using here by temporal loads, by using a technical inscription timeline in the source system to really track when this transaction happened. And we will use that to load into our data vault, and this is already having the right name, which is CDC inscription time, but I would need to rename it if it would be another name, but that's possible here. I can add commands. I could do delta and filtering here. I'm not doing that for the time being. I can add this later. This tool is built for agile development, so I don't need to worry about it adding stuff later. And here we see a big advantage of connecting directly with the database. So the Datavault Builder is working already with the target database. It will create a table, the ETL flow, and it will immediately load the data. So after a few seconds, the objects are created, the data will be now loaded, and it will tell me when it is ready. It automatically added this to data lineage, to operations. We can generate later on the documentation as well, based on what we have here. And let's have a look in this table. And this table is already filled with data. And as this is a small table, we see it very well here, but we could go as well here to the data viewer. And let's analyze it and let's group by stuff. And this module is sending directly queries to your database. So if I say I want to here do something maybe and group by order ID, we will see that it sends the query directly to the database. We see now orders with different amount of orders, and we see the biggest amount that we have here. The biggest order that we have is order 1, which has several lines, stuff like that. We can do here like a bar chart as well and see how the values look like. But I need to move this over here. And we see, yeah, that doesn't look too interesting right now. But we could go in here as well, double click and filter if there are less records. So let's do maybe something different. Let's do the opposite. Let's take the orders with a certain amount of lines or quantity. See the value distribution, and here I could as well go and filter and stuff like that. To share this with my users, I could create bookmarks, but this is not a reporting tool. This is really a data profiling tool to see if there are any null values, if there are any data problems that I would see already here that could appear later in the business rules. And now we need to connect our source data with the object. So let's go to the order line and let's add here load. Let's select the source system, the only table we have. And now I can check for uniqueness. And I would check first, is the position ID unique? And if not, I would probably guess that the order ID needs to be part of this business key. In this case, the position ID is unique, but I talked to the business user and they tell me that we need to put in the order ID. It could be in the later case that position ID and order, the position ID is only unique in combination with the order ID. Good. So let's go on. We could prefix values if we have data sets that are combined into a hub but should be kept distinct. Like if you have orders from Switzerland, Germany, they have the same order numbers, but you don't want to mix them because they are not the same orders, even if they have the same order number. Now I go for the fast track. I let it create automatically a satellite. I could do it manually, then I could split them. I could define conversions of data types, but for the time being, we don't have many columns. There was like an interface created for us. That's perfectly fine. We just create one satellite where we put in all the data. This is now a production ready implementation. So what did it do? It created the hub load. It created as well tracking objects, which are not visible here. These are technical artifacts that are created to track if something was deleted in the source system. It created satellite load, and it automatically goes back as well to the staging area. And that's possible because we have here standardization about the layers. It will extend the staging tables with a business key and a hash key, and it will as well create, change the ETL process to pre-calculate business keys and hash keys in the next loading. If we go in here, in the meantime, the data was loaded. We have the hash keys, the business keys, and we see now standardization by relying on Datavault. So we have 4 columns given by the Datavault standards. We have some standardization that I don't need to define it on the naming, like _h, _bk, and this allows us to send you update scripts over the time when the database improves or if the data modeling needs to be adapted, and we are managing for you that. So we are protecting your investment in the data model you're doing here. The same is valid for the satellite, so we can go in here, load the satellite, and that's it. So let's go to the next layer, because just because we load the stuff to the raw vault doesn't mean that anybody can access it. Nobody should ever access the data vault directly. So let's go to the dimensional model. Don't get confused here. It's possible to create your dimension facts, but as well to create third normal form output, flat tables, data products. You just choose the grain of your output, which would be here the order line in the first step. We can select if we want to output all the keys in the hub or just from one source system. That's what we're doing here. We can select the STD type for the output. So it will tell us, do we want to have just the as of now view, STD type 1, or the full history, STD type 2. And we can create more than one interface per grain. I select now the very simple way to just show the data to the consumer. And later on we will create as well a as of 10 interface, including all the full history. By the way, just the distinction, the history while loading the data is already created in the data vault. It's just the view that I sent to the reporting layer that is now simplified. We see the blue box. It's a core business concept with the satellite. We have here a lot of gray hubs or concepts, and this is because they are not implemented yet. So the links are not implemented yet. So I could already add them to the output. So I have a prototype interface, but for the time being, I don't want to do that. I just add here most of the columns. So I want to have the order ID. I want to have the order ID will coming from the order. I could put in for debugging right now as well some more columns. Okay, let's store that. And as this is virtual, I don't need to reload any data here. I could rename the columns here for the interfaces if specific consumers want to have a special naming. And we can preview the data here already, how the consumer will see it. And the last thing that we need to do is we go to the next layer. We decide that we don't want to implement any business rule yet. We just publish it. And that's the minimal run through from source system to the output with historization, with documentation, data lineage, and everything that you do in the Datavault Builder. So let's have a look here in our data preview. Let's look at the order line. And we could take here the product ID, and let's maybe sum the amount. And let's see what is our most sold product that we have. And we see product 1 is the most sold, but we don't see yet the name. So we need to link it that we get more information. And this is exactly what we will do by extending the model. We will see here more and more information. So this was the minimal run through data model, step 1, staging, step 2, connecting the stage data with the model, step 3, and creating interface, step 4. And this will repeat now. And we will go faster and faster the more we progress. So let's add now the order as well. And we don't need to add a new source system, just a new table. The order is the Bestellung. And I say I want to add here one more table. I want to add in this process now as well the product. I don't recommend to do like everything at once, but go step by step. But we have seen that we want to see the product name, so let's add this as well. And the order, so we get a little bit more stuff here. And as it's server based in the background, it's already loading, the data is ready. So let's go directly to the next step. Let's add here the order. And we know that this is the order ID. Why do I know it? Because I started here at the data model and I talked to the business users. They explain us what it is about. It's unique, so that's perfectly fine. Adding the satellite. And now we have already 2 hubs loaded with its corresponding satellite. And now we need to start linking the stuff together. For that, we take what in classical terms we would take, it would be the foreign key from the order line pointing to the order. Let's add this. It's foreign key definition. And this will be the order ID, Bestell ID. This is not unique. And this is exactly what I expected. I just wanted to check it. So there are more positions for one order. We can go in, we can see an example set, we can check if this makes sense. And that looks perfectly fine. So let's go on. It will automatically not check the box keys are unique because it will need to normalize out this foreign key out of the positions. And this is as well the same way as we can as well normalize out satellites from the normalized files. So that's supported just out of the box. And after defining the foreign key, we just need to define the link load. And by defining the key for the position and for the header, it knows what the keys are. I don't need to define here anything, just say I want to create it. Now, let's go back and extend the interface. And I don't want to do now, for the time being here, effects dimension thing. I just want to do a flat output. And we see that now the order appeared here in blue, so this was implemented. So we can go to the order, double click, it will reload everything from the database that is connected to it. Let's take the satellite. And we can add here some attributes from this satellite. And you will see that this will be empty. And I did that on purpose because I didn't load the link, I didn't load the hub, I didn't load the satellite. I could do that manually as I did it in the first step, but I want to show you now a second way. Just test that it's really empty. Let's go to the operations module. In the background, the job was already created and it includes all the necessary steps, so we can just start it here. We could already schedule it here that it would run daily. We can use external APIs to trigger the job, and now everything will be run in the right order. And a few seconds later, we should be ready, the data loaded. So if we go back here, now the data is loaded. And we already linked two hubs together. And we can go on, we already staged the product table. So let's add here this load. And let's do adding the link. And I'm doing it now a little bit different just to show that there are different variants. So I don't define the foreign key yet. I just say I want to add the link. And while creating a link, it tells me that I didn't define what will be the key linking the position to the product. So I can do it at this point in time as well. Just need to select the product ID, check that it's not unique. Yes, that's perfectly what I expected. And let's add this. Now it goes back to the link dialog. Now it will know what the keys are. That's perfectly fine. And in this simplified example, I'm showing everything with binary links. There are as well links that can link one hub to many other hubs. And you can use that as well in dimensional model. But just for simplicity, we're just showing it now with the very simple ways. So let's go in here. And now we could as well extend here our order line. Now the product is here as well in blue. If I double click it, it will load the satellite connected to it. Let's add here maybe the name. And let's go to operations, reload everything. And we can now go back to the data viewer. And if we refresh here the interface that was updated constantly, we will receive in a few seconds here as well the new columns. So instead of showing here the product ID, I can take here now the name of the product. And it already makes a lot more sense. So slowly we're creating that, and we just need to model it once, we just need to connect it once. And in the background, the value of our network is growing. And we see now here that the Amaranth Mischung, which is the Amaranth mixed thing, is the best selling product that we have. I will split the video here, and I will now go and connect more and more data based on this data model, which will be the next block that you really see everything being created in real time. And you can skip that because it will be repetitive, but you will see how long it takes for me. And in the next block that I recommend to watch is when we will start working here on the product and the product category, which is hierarchical link, and how we can build this in the tool and how we can use that. In the last part, we created the order line, the link to the order, and we loaded the product, and we created the link from the order to the product, and we created the interface, and we checked the data, and that's good. Let's go on with the next things that we need to add. And so let's have a look in here what we want to integrate here, and maybe let's go to customer and the partner to add this stuff. So I add here now the customer, Kunde is customer. And let's add as well the gardening community that is referred to, by the way, here in the data model sometime a little bit different. Here it's the German term is Vereinspartner, which is pretty clear. Let's add this. Let's check if the customer ID is unique. That's perfectly fine. We don't have that much data problems right now here, and they are added later. So there are exception cases as well mentioned here, where we have different disk cases which bring like missing business keys, duplicates and stuff like that. But here it's plain vanilla what we do in the first step. So we added the customer. Let's add here as well the club partner. Everything's worked out smoothly here so far. And now the interesting point is that we have now two relations by these two different hubs. And one is telling that the customer belongs to a partner, and based on that he receives some discounts. So let's do that first. So we define now from the customer table the foreign key to the club partner. And this will be hopefully not unique because there will be some gardening communities that have more than one customer. So that's perfectly fine. So it automatically clicks keys are not unique. It will apply a normalization when loading these hub keys. And we can add the link load here. And now the interesting thing is, in the definition here in the data model, it tells that one club partner is represented exactly by one entry in the customer list. The club partner itself is as well a customer, but is a special one, and this is marked by this relation. So we now take the data from the club partner and we add the foreign key into the customer. And this is now here, this entry identifying what is in there, and this should be unique. One club partner is exactly represented by one customer, and one customer can only represent one club partner. So that's fine. We will not create any satellites. We just create here the foreign key definition, and we add the link load between the two. By the way, because there's a one-to-one relation, we could have omitted creating the club partner here and taking this attribute satellite here, creating it as a self-link. All potential ways to model it. I think this here makes it more clear. That's why I decided this way, but you're open to model it as you need it. So there are the two options. just that you know that this is not black and white. So we added already here some entities. I want to add here as well the relation from the order to the customers. Let's do that. And this will be from the order. I hope there's a customer ID. Let's check that as well. I expect that this is not unique. And you see already I'm quite used to just click the granularity check button to check my assumption about the data. And this is the big advantage in the Datavault Builder, that this is integrated in the flow, that it's really a second click, so you do it and you don't miss anything that could be unexpected. Let's add the load. Let's add the relation. And you see, as soon as you got the hang of it, this thing is repeating. And here what we see is, it tells me that for this table, it knows both keys, so it can already create it. For this gray one, it would need to at least know the foreign key to link the stuff together. So let's add this. In the background, again, I kick off the load. And you see already it's getting bigger and bigger in here. So let's go back in. What could be the next part we're implementing? And we have here the leveradresse, that's the delivery address, and we have the woonort, which is the address of residence. So let's add this too in here. And I have normalized them out because there is a history of these addresses in here. So they are not at the same grain as the customer. If it would be just an attribute of the customer as of now, you could load it as a satellite, but here we're loading it here separately. What I haven't done and what I usually would do, I would already test the stuff that I have done. And I have forgotten this because I was so happy to add here more and more stuff. So I will do this in the next step, don't worry. Let's go now for the addresses. So let's add here now the delivery address. And there is a lever address ID, which is the delivery address ID. This is already unique, so you say it's a really nice data set. Usually you would run into troubles again and again with this kind of business key checking in real world scenarios. And honestly, we did as well in earlier stages of the data sets that we had here. These data sets were improved as well on feedback by the different participants. And now the data sets are already very clean, except they're on purpose having some data problems that need to be handled by the tool. And here is very interesting. Here we don't see now a special ID for the address of residence. So if we take here just the customer in, we will receive now duplicates. And if we look into one data set, we already see here that there are different validities. We can sort that by the validity. And we see that this is a prehistorized table based on business values. So this customer lived at different addresses over time, and it's perfectly fine. You could store this in Datavault as a concept as a multi-active satellite. We are doing it here differently. We are doing a sub-partition hub, so we are taking at the grain as the data is coming in exactly here. This object, address of residence, and I will use the customer ID and the valid from date as my business key, so I can link as well later directly to an instance of this address. Good. Now let's link the addresses to the customer. And this will be one from the delivery address. This shouldn't be unique. And again, I showed a different way of adding it. by not defining the foreign key first. So I'm adding here the link load. I select here just the table. It tells me the foreign key is missing. So I just need to specify the foreign key. Please don't get angry that I'm calling it foreign key, but this is a concept from entity relationship modeling, not from the Datavault terminology, just that people understand what I'm referring to as an idea. And now we can add this link. And we implemented this part as well. So let's go to operations, load all these jobs here automatically. And to test it, what we have created, let's go in here and let's create here something new, like the link from the order. To the customer and maybe to the club that he's participating in. And we see here we can go from the order, the customer, and to the credit card, but we can't go to the order line. Why not? That's on purpose. In the data model, we have already created here the relation from order line to order by defining a direction of this relation. So this is not at the Datavault level, this is at the logical data modeling level, but this allows us to prevent data fanning later. It helps to automate the driving views and everything, so we don't need to create this manually. And here it will prevent us to doing the most common error, probably even creating interfaces to link in the wrong direction and creating a data fanning, so multiplying one line of data by multiple target lines. But we can take from the order now different elements. And we can go here to the customer, double click. We can go to the satellite of the customer. Maybe let's take the customer name and first name. And let's go to club partner. And now the interesting thing is we have now two different paths. So this normalized view that we have here is split up into distinct paths. So we are here more in a kind of denormalization view. And now we take the customer belongs to a club partner, and we want to take the attributes of the club partner he's belonging to. And we can go on then, and then as well take by which client it is represented and get the name of it. But here just take the club partner general name, or no, it's even only the discount. That's not nice. Let's take the first discount, but let's go as well back to the customer, and let's take now the attributes of this customer. And let's hope that we will see here the name of the partner. And it tells us we have already 2 times the name in the output. So let's call this partner name. Let's store that. And it's creating now all the joins in the background. It's creating this as a view. This is the first version, it's always virtual, so we don't need to reload it. We can materialize it later back in the business world. Let's have a look. And we see here already some of our clients are participating in a club. Others are not, they are just buying. That's perfectly fine. Let's have a look on which are our most successful partners. Now, it's a cool part, yeah. But let's look at the biggest gardening community that we have, Eichberger. And here we now see the clients of it. So we've already validated what we have here. So let's go in and publish that already for our client. And he can already start testing. So in this section, what did we do? Is we managed to extend our data model. We can now highlight which parts of our data model are already filled with data. We are missing the product and product category. We are missing the delivery. And we're missing the part of the credit card that we will use joining together. And I would say that I will go now in the next section with the product category, which is a hierarchical link, which is more interesting now because it shows you a little bit how to denormalized and as well a hierarchical structure completely without writing code. So our next challenge that we want to have a look at is here in the area of the product. And the product, let's see if I can zoom here in a little bit. Not really. Let's open this image in a new tab. And maybe we can scale in here a little bit. So we see that we have the product, and the product is linked by the product category to a category. But the category itself is linked to a parent category. So how do we model that? And in the Datavault Builder, I've decided here to use the pattern that we have the link of the product to the product category, and we link from the product category to a parent product category. But the parent product category is not really an object that will turn into a hub. It's a alias. This is represented by the two green lines. So in fact, it's an identity. It's just an alias. It's a different name. And we use that so we now see exactly in which direction the link is going. So it could be like from employee to manager, and here it's going from product category to parent product category. And we will see that we can use this circle round and round to extract several levels of categories. This makes especially sense than doing visually if there's a defined number of hierarchies, but we could use that as well in a CTE expression or something like that if there are unlimited levels or unbalanced trees, stuff like that. So let's stage the data first and connect it. Let's go in here and select the corresponding tables, which is category. And let's stage this. And there's one more thing that we need, which is, I think, the link to the product category. No, we don't need that. That's within the category itself. So let's have a look at the data. And while we were looking at the data, we realized that there are sometimes issues. And the issue that we have seen is that there are, in fact, spaces behind the names. And that's possible that certain sources don't deliver the proper data, and it depends now business-wise if the spaces are part of the business key. Could there be a difference in the source system between Kartoffel, which is potato, and potato with space? If yes, we will need to keep it distinct, and that's what Datavault Builder is doing by default. So it's accepting all the characters coming from the source as the relevant characters. Like we had one client that had smileys in their business key. That's perfectly fine. So Unicode characters, Japanese, Chinese characters, everything's fine. We will work with that. This is regarding which database we use. So we use different methods to really binary compare this kind of stuff, that nothing is lost. But in that case, we talk to the business and they tell us, yeah, that's not really a real world use case, that this could be different. That's just typos, or in the export, there's some kind of error. So what can we do? And for sure, we could load it into a persistent staging area in here. We could create business rules, clearing out this stuff, and go back into the raw vault. And we would have full auditability, it would be traceable and everything, but we would create several steps that we need to manage. And here in that case, as we got signed in blood by the business user, that this is just an error, that we can fix it while staging. We go in here, go into the in the column section, and here we select a method that we want to change this staging statement. And how I can do that, this is being sent directly to my source system. So in that case, I will be using here rtrim. I know there are some of our clients that are using rtrim as the default for loading the data, but please be aware that this is not the best solution for many things, especially if you have really source systems where this stuff could be differentiated. Maybe not today, but maybe by accident later. So let's test that, let's store that, and execute against source. So let's validate if this is still valid SQL statement. He's happy. So that's very good. So let's go on and load this immediately. Go to the data viewer. I can type like nearly everything. So we are looking for the category, in German just written with a K, not with a C. And so let's look if we have category ID and parent category ID. How this looks like, and maybe let's do it the other way around. And now we see, yes, that in different categories there are different stuff in here, and the name is as well a little bit different. So that looks good. But what we don't have is that we could filter here like for category ID. Just look for the G. And we will see this one has no parent category. So this is already the parent category. But if we take here maybe GMI, then we will see it. GMI links to G and G links to nothing. So that's kind of a small hierarchy that we see here in the data. So let's go in here. Let's create here a load of the category. And here the key is the category ID. That should be hopefully unique. You can create automatically the satellite. And the funny thing is, if I load here the product category, and I switch over to the parent product category, this is identity, it's just a role play, it is not a separate object, it's just a view that is created. Even if I have no loads here, I will see the same values and data that I loaded into the so-called base hub. Good, and now we can create the relation. So here with the product category and here to the product category, how is that linking? This is linked by the Obercategory ID, which is the parent category ID, and this shouldn't be unique. Happy luck that we have that. So this looks very good. And let's add it. And now we can create a relation between category and parent category ID. And what we need to do is now to add the link from the product to the product category. This shouldn't be unique. So everything's fine so far. That will link the product ID to category ID. That's perfect. And as you see, I always concentrate only at one thing at a time. So I can profit now from everything that is already implemented in here, but I always work on a small bit so I can extend it step by step and just make the model bigger and bigger. And while I'm creating the output interface, I start all the loads. I could have done it manually while creating the stuff, but right now I'm just lazy. I just kick off everything. And in the meantime, I do here my test. So I go to the product, I create the interface, add the grain of product. I don't add here any function yet. And so let's take here now the product name. And yes, let's add some more attributes that we get a nice dimension. And this is not yet using the link to the product category. So let's go to the product category. Let's go to the satellite, and I will do it very minimal. So I'm just taking in here the name. And name is confusing, so let's rename that, store that. It writes all the link in the background. And I have now two paths. So I could go just to the alias to use a differently named business key, but for the same row, or I can go to the parent category. That's what I want to go. So I go to the parent category, and from that to the definition of the object itself, where the satellite is attached. Before we go there, let's preview if we have no errors in it. That's usually what you should always do. And we see here already that something's wrong. The product category is here empty. So I've did probably some kind of mistake. Let's check that again. And something's wrong. And what happened? I checked in my notes, and the problem is that if we look at the product, then if you look for the product category in here, then we have the same problem with the space. So we fixed it on one side, and by that we created a problem in linking to it. So let's fix that as well. And I did an error here. Not good, but you see it's really live, and we try not to edit it except there are some like lunch breaks. So what did I do is I forgot to put in here first thing semicolon. Second thing is I didn't check it if my SQL is working at all, and I just assumed that I'm not doing any mistakes, which is usually not a good assumption, especially shortly before lunch break. Good, so let's reload everything now. Let's see if this works out. By the way, all these log files are accessible as well directly in your target database to read as SQL. And there's a REST API, so you can access it. So everything which I'm clicking here and starting here jobs you can use, running UC4, Chronicle, whatever system you're using, or Airflow to start stuff. Now let's go back here. Let's preview now what we have in here. I hope the load's finished in the background by now. And we see at least for some of the products, we do see here a relation to the product category. And now it loaded everything and it looks now good. So let's go one step higher. So we go to the parent product category. Let's drag in here the name. Let's store that as well. And do it for one more level. And honestly, I'm not really sure that there are really 3 levels of categories. I'm just adding it. We will see it when we query it, if it works out. Let's preview it. And that looks already very good. And this is like the parent category that we have seen, Gemüse. And this will change as well over time. So what we will see then when we will load different days of data, that this relations change over time, and we can track that, and everything is as well tracked correctly, and we will have full history that maybe some stuff is recategorized into other stuff. But for the time being, we tested the data, we see that it's linking, so we are happy for the time being. We can go in here and as well publish our product, call our consumer. Can you check that bit? That doesn't, please, doesn't make sense with the categories, parent categories, and everything. So we finished now the part with the hierarchical link. You've seen so far we did change, we wrote some kind of SQL code, and that was here in defining the source statement, where we decided that we really wanted to R-trim our sources, but otherwise than that, modeling the hierarchical link, creating the interface here, and writing here the output rule was just happening completely automatic so far as well, including the renaming. I could define it here in the model-based definition, and that's it. So in the next step, we will go to the next part of the problem, and this is which is covering here the delivery, because here we want to then capture the punctuality. Just to see where we arrived so far is that if we look here, which elements are already loaded and which are not yet, we see that we have the order line, customer, club partner, addresses, product with product categories, and here the delivery part is still missing, and the credit part is missing that we need to solve in the next steps. After we have created now part around the customer, around the product, we have the order where we started off, let's have a look at the delivery and later on the punctuality. So let's have a look at the model, what it tells us about this. And if we go down here, see that every position is delivered and we have no partial deliveries. That's very interesting, but that's how the business runs here. So they wait until they have everything, or otherwise they would split the positions, and that is described in the use case. And we have here delivery service that is doing many deliveries. So let's have a look on how we can stage this data. This is coming from the same source system. And I check if there are any specialties, but I guess not. So Lieferung is the delivery itself. You probably already know this part, so we just stage the two tables relevant for the deliveries. And I stage them directly, so I have already the data ready. And I could go in the data viewer, analyze them, but for the time being, I think these tables are pretty simple in here. So let's add the delivery itself. And now it is interesting, what is the business key? So we have the position ID and we have the order ID. So let's go back in here. And we see we have the order and the position ID linking to the position. It's going to a delivery address and it's going to a delivery service. But this part here is not identifying. It could change over time. They could order and maybe they could correct something. They could reassign all the delivery service if something's going wrong. So just as key, we take the order ID and position ID. And you see we have no additional key, and that's exactly why we can have only one delivery for every position. But that looks okay for the time being, so let's check that if this is really unique. It looks good. And now I do something different, just for doing it different, but as well because here I have 3 columns and 2 of them are in fact links to other entities or other core business concepts. So I will not create the satellite automatically. So we'll see now as well how to manually create a satellite. So we have added the upload, it added tracking objects to track if something was deleted in the source system, it was added to operations, everything, but now we need to add the satellite additionally. And here we can select the columns, and in that case the only attribute that we want to store is the date. I could put in as well the order ID and position ID separately, but I assume I can get them always from the order itself, so I keep them here out to make this very lean. I could go here in, and if the source data type wouldn't be like a date already, I could do here some type conversions, and they are lossless. So this means it will keep the original data format, plus it will try to convert the values, but if it can't convert them, you still have the original values, or you're not losing any information. And that's the difference to when you would like do this already in staging, where you can do it already as well. There, if the implicit convert does work, it continues, but if it can't, it would fail the staging load. And here, still, if few rows can't be converted, it will continue. It will keep all the data as it is, plus convert the one that can be converted. So let's do that. And now our model is getting bigger and bigger. We can start loading this one as well. And I will add here now the relation to the order line. So I'm adding here like the foreign key definition. And here, if I want to see what the business key is, we see here already we had the order ID, the Bestell ID, and position ID. So I can already preview that. I can check if there are still multiple deliveries. No, it's in fact a one-to-one relation, but logically I would still model it probably as a many-to-one, because I would expect that at some point the business could change and they could have partial deliveries. So its clicking keys are unique. I will deactivate it and say, hey, it's fine. I already assumed this could change in the future. So that's perfectly fine. So it already proposes you something, how the stuff would look like. But here I say, I know more about the business. I know about the future plans of this company because they told me. Then I can still override what the system is proposing me. Good. And that's it. So we now integrated the delivery. The change that we have done here was the manual satellite. Now let's go to the delivery service. And now it gets very repetitive because this is how it will work. And we can extend the model and everybody can extend the model and it will be always the same. So we have now the delivery service. We can have a look. It's the delivery service ID that we have in here. By the way, this is a very nice system where business keys and technical keys are in fact the same. So we don't need to work around a lot, but it could be that it's different and then there are different ways to solve that. Good. So we added the delivery service. Now let's add the relation from the delivery. I would expect that this is not unique and that this works perfectly out. So yes, delivery service is delivering more than one delivery. That's cool. Otherwise, that would be probably already under chapter 11. So add the link load. And again, I'm now a little bit lazy, so I will not load all these loads manually. I just go in here and slowly we see that more loads we get and how this is evolving. So it runs now parallel within a layer and it runs as well parallel between the layers. As soon as the first staging table is complete, they are already loading in the vault while still other tables are being loaded. And this optimizes the balance and usage of the resources on the database, which is below. Good. And as we should always test what we're creating, so let's take the delivery, or let's start in fact, no, we do the delivery first, do part by part. And what do we see here? So you can go from the delivery to the delivery service, but we can't go from the delivery to the order line. Why not? Because I did a mistake. When I was creating the relation from the order line to a delivery, I was assuming that many deliveries would be in one delivery, and that's simply not the case. That's the wrong way around. So let's remove that. And let's create it the correct way. So many deliveries from one order line. That's what I intended to do. I don't need to define the business keys. They're already there because I defined them for the upload. I just inverted this link. Now as I just changed this link, I just reload it. I go to the dimension model, double click, and now we see the order line. Cool. So let's go in here and we could add the different columns. And we can take stuff from the satellite, which will be only the delivery date. That's the only thing that we have in here. We can go to the order line itself, to the satellite of it, and let's maybe add the position ID and the order ID, the quantity, price. I'm not interested if delivering stuff. Good, and we can go to the delivery service as well and select here from our delivery service the name, and that's it. So let's test if this works out, if we did any mistakes. What I see here that we have not yet linked that to the delivery address. So this information is missing. No worries, we can add that. That's why the Datavault Builder is built for Agile, so we can do this first. And the interesting thing is we have now lots of delivery without order ID. And there are two reasons for that. Either we did something wrong, it looks like, or we haven't loaded something, or it could be that it's only partially filled. That's why you can filter here for not null or for top occurrences. And somehow something went wrong because we have no quantity, no position ID, and this is all coming from the position. But we have the name. So let's go and debug that. So let's have a look on what happened. We have the delivery itself. So let's have a look at the delivery. This one is loaded. We have data. We have seen that. We had the business key. So that's not the problem for sure. And we have a link to the delivery service. That's what we have seen here as well, that the delivery service name was filled. Maybe let's rename that. This is right confusing if it's just name. But here the link to the order line somehow wasn't working. So the reason is that I clicked on the wrong reload button. So you see we are not doing here any cutouts. We're really working in real time as well to show you debugging. This is how we build up the model. Just that we have the knowledge up front, that we already studied all this and we know the data problems because we had a look at it before. But the working with the tool is really happening in real time. So let's go back here, and that probably already solved the problem. And that's as well the important thing about the Agile approach. Test right away what you have done, so you see really what happened and if you done any mistake, and now we see that everything is filled in. So that looks quite okay. And as we tested before, the link from the order line to the other elements, that's fine as well, so we don't need to care about it. And by the way, I did filter here a little bit down that we can concentrate on the part we're debugging, but the whole data model is still there. We can still go through the data model by double-clicking, browse what is everything connected to it, the credit card, the customer, and we can go through and through. And this is cool if you want to explore your data model, but it would be a pain if you need to do it really every time and look for everything. So I will do now a shortcut. I can do this only with smaller models, and I bring now the whole data model to the screen. And what I can do now, if I arrange it and I like it how it is, I can create a bookmark. I can share the bookmark with my colleagues, and like this I can as well show some excerpts from the model to my colleague that is maybe new, and I tell him, look, concentrate only on this data domain or stuff like that. And this is exactly what you can do as well here. You could go and say I want just a subject area of logistics, and it shows you logistics plus everything which is connected by one edge. And you can focus on one little part of the model. Or we go now back and we recall our bookmark and see exactly what we had before. So what did we finish in this part is we added the delivery service. We didn't work yet on punctuality. Punctuality is the difference of data of an order when the customer wanted to receive it and when it was delivered. So late deliveries are bad, but for Willibald as well, early deliveries are bad. And this is what we need to check in the next step. And for creating this kind of categories, we have received a mapping file. The mapping file is part here of the use case. So we go down here. In fact, it's coming, I think, as description, and we have just stored it in an Excel sheet. So our business users are able to work with that. So let's create a new source system. We call it Termintreue. And let's give it a shorter ID like TT, that's fine. And this would be an Excel file. And let's copy the file name in here. And there will be two different files, one for period 1 and one for period 2, and we will load them separately, but right now I want to load the stuff for day 1. Now has header rows, that's correct. And now it will parse the Excel file for sheets, for tables, for named ranges, and offer me this kind of information in here. And what we need to now is add is, I think, there should be only one table. And the table is missing, so I did the configuration errors. Let's go back in here. Let's check what I have done, and I see it. I added here 2 times /files. Let's go back here. Now it finds everything, the table, and we get everything that we need. And in fact, there's just a limited amount of data that we want to load. Stay from 2. It's like if it's between 1 and 5 days delayed, then it should get a certain category, and the category is here in the name. And there will be a rating as well, how we see that, if this is okay or not. And now we have a column here called inscription time, and that the system recognizes that it will be our external timeline that we will use as we need. We are not loading at real time, so we need to place at which point in time this stuff happened. With a normal Excel sheet, that wouldn't be the case, but this here for this example, that we can really differentiate between the two simulated days, it's what we do. Good, so we map just the inscription time to this standardized column name CDC inscription time. We don't need any delta parameters. And let's load this table directly. And we will see if it works out. Looks okay. So we can have a look at the content. And we see already here the different stuff. And the weird stuff that we get, we have like Y, Z, X, X in here. So, whoa, what is that about? But the good thing is this is described in the Willibald case. These are exception handling. And they say this is like not yet relevant because it's not delivered yet, irrelevant, whatever. It's like selling off something that is directly sold off the ramp. So there's no delivery, and oh, that's an error. Good. So we have received that. We just, as a first step, go to the vault and materialize this information. And certain systems know, or Datavault knows this, the term of a reference table. And this is a perfect example of a reference table. And you could implement that just and copy it into your vault without historization and everything. But we figured out that it caused a lot of troubles, because at some point your business user uploads a new version, they do an error, your reports change because the mapping changed, and you can't prove what happened. So what we do is we still model it as hub in combination with a satellite, but we create a special current view of the satellite directly while loading it. So you can access always the current version of the data, but still you would have the history if you need to figure out later on what happened, why stuff changed. So it's covering body parts that are really important to you. So let's have a look on this punctuality thingy. What do we need to think about it? We need to load it here into our punctuality hub. just to load the data, and then we need to somehow create a relation between the order line, calculate how late it was, and then add it here to punctuality. So let's do that. Let's add the hub load. We'll have the system termintreue, which means are we on time or not. And we will use here as the business key the days from, because we assume there shouldn't be any two entries starting with the same amount of days. We don't take here the 2 because we say yes, this could change as well. The name and the rating could change. So let's test if this is unique. Hopefully yes, that looks good. So key settings are unique. We can load the data, and let's load it. Now what we need to do as next thing is we need to put in some rules on top of it. And this rule will allow us to create some business rules that we will need to derive certain values from that. So let's go to the dimensional model. Let's create here something based on functionality. And that's quite common if we get Excel sheet that we have some business rules, massaging a little bit the data. I take here the as of now view. I just want to get the latest information. And let's have a look on how this looks like. I don't put in any function. And let's drag in the columns that we need for our business rule processing. Let's store that. And let's preview the data. It should still look the same, but we see that I've missed to load it. And I'm in developer mode right now, so I can just load the satellite. It will recognize the hub wasn't loaded, and it will load the hub first and then in the satellite. That's a configuration setting that you can change later if you want to have more control, if you just want to reload the satellite without reloading the hub. So let's have a look at that. Let's preview it. And now we have the data here. Cool. So let's go to the next step. After we have calculated here now the delay of the single orders, let's have a look at this. We want to look up now the category of the delay. And these categories of the delay are delivered by the functionality table. And here we have some challenges because we see there are different days from to, but we have as well some non-integer values in here. And if we do the lookup just right away, this would fail because we need to convert the days into integers that we can really compare them correctly. Otherwise, they will be compared in a text mode, which would be wrong. So let's start working on that. And instead of extending this rule here, I'm creating a new one. Before I do that, I rename the existing one. If I want to do stacked rules, I can here use some numbers for ordering of the rules. That's what some of our clients do. It's not mandatory, but I like the idea, so let's do this like in basic. So let's take that. And what we need to do is I will be using as input for the second rule the first rule, so I don't need to calculate again how much delay we have. And so I can copy and paste here. What I will do here is I can clone my environment. I show you how to do that. So I go in here, I just say duplicate. Can go now to the business rules section and say, okay, I want to take this here as input. So this will be my base. In the second rule. And what I want to do as well is what I'm interested is this termintreue. Just for debugging, I will add it to the output. And let's see what happens. That looks good. And now we want to go for a lookup of this rule set. So this will be our target. We will do a left join so we don't lose any data. And we will use here, and I will do this now. I already know some problems with this lookup table, but I will show you how we discovered that, so you really see how this works. Because the issue that we have here is that between includes borders. And so if we have in the data borders which touch each other, we will have here duplicate lines. And it's telling me that I did some typo. Yes. This is a filter on the lookup table. So let's do that. And we will see here, this is valid SQL probably, but it will work not out because here termintreue is an integer value that I'm comparing to some text values. So it will convert implicitly the values into integer. So if I try to refresh here my preview, it will fail and say, hey, there are values like y that can't be converted to integer. That doesn't work out. And how do I solve that? I go to Punctuality and I say, let's preview that so we see really what we're doing. I'm just thinking I could have checked it if it's a number or not and filter for that, but this will work as well. I will not win a beauty contest with that. Good. Now let's go back here. And I assume that this will now work because now this will work anyway. This one here should work because now it only compares it to integer values. So that's really great. Now instead of outputting it, we go back into the staging area and we create our first business vault load. So it will be a Webshop business vault because I want to create a new link. The type of the connection is business vault. We don't need to specify anything. We know where the business vault data is coming from. And it's complaining. Let's take another ID. That's fine. Good. And a few seconds later, it will appear here. Because my screen is a little bit longer than what I'm recording, I just filter here, can add it here. So we select here that we want to take a business rule from the Webshop source. And what we're doing is here's the group lookup. And now what I see here that I missed something. I have the order line in and I have the termintreue, but I don't output yet the business key that I need to create the relation. So let's go back to the business rule. And what we will output here is the business key for the functionality as well. Looks better. So just stage the business keys. Why are we going through the staging area? So we can use as well delta loading in the next step, stuff like that, just that you know where we are. Maybe shortly diagram. We've been in the Datavault area. We've created our dimensional model, a business rule, and now we're going there back where the arrow is the business vault. So logically we're going back to the vault, but technically we're going through the staging layer. And we need to create a new source system because it is possible to create more than one business vault system, and we can run different layer of business rules. I rename it just that it's a little bit shorter, and I can load it immediately. So it will create a target table, it will create a load and everything, and it will stage the data. And in the vault area, we now say that we want to fill this link, and to fill the link, we need to define the keys for both sides. So I go first to the left hub. I have the order line. I don't need to retest it theoretically, but maybe I've created a fanning problem, and wow, as expected, I have created one. And what's the problem? We can preview here now the problems that were created. We have 2 times the same order, and it falls into 2 different categories. So what's happening here? So let's go out here and let's go back to the business rule. The cool thing is we can here beta test directly what's happening. We see it's in 2 categories. And why is that? So let's maybe output as well the lookup borders that we are using. And we will see immediately what happened. The problem that we have, oops. That was the wrong copy and paste. Don't worry, we see it here already. That this entry is at the border on this category 0 to 1 day and 0 to -5 day. Why? Because it's on 0. So it's on this border, and that because we are used to be in between here, links both of the entries. So what I will change it here, equal so the business key checker already prevented it to load any bad data in there. Now let's have a look if this works out. We have only 1 row here. So we need to restage the table, and now we can go back and start adding here the business key. This should be unique now. Great. Let's define a business key for the functionality that we're linking to. And this shouldn't be unique because many rows will link to the same category. So just test that if my assumption holds true. And that's correct. There are a lot of records that are delivered early, but we can check that. So let's take maybe here one of the examples and see if there is any issue or if this holds true. And it's really -6. We can take maybe a second one. Wrong here. -7. Looks like that's the data as it is. Good. So we created now the both hub keys. Now we can create a link in between. And that's it. And I will on purpose not reload the link here manually. So when we go now here to the order line, we can add now this new information that we just linked. So in the existing interface, we can go now from order line as well to punctuality to this satellite. And we can add as well here some information, days from, day to, so that we will see this category. Let's store that. And if it's saved, we can preview how the output looks like. And I assume that these columns will be empty for the time being. This is what we have here. And why are they empty? We never loaded the link. And now I show you something different. We can go to the job for the raw vault. And I can add here that when it's finished, it should load the business vault. And that's it. That's how you define job training. And now everything will run in the right order. So it will first stage the data. It will load it in the raw vault. When it's finished, it starts running the business vault calculations. This will take about around 1 minute. In the meantime, we can explore documentation. We can look how long it takes to regenerate it. This is really based on the real implementation in the database. We can have a look at the data lineage, how far we progressed so far. So we have now 2 different source systems. We have one business vault load. We can start filtering down here and see now from the left side, from the shop to the staging table, to which elements are filled, how the stuff is joined together. And I will explain that later in detail. So let's go back to the job. This should have completed by now. And when it completes, automatically it triggers as well the job which is connected to it. So it will as well stage it, load it. And that's it. So if we go back here to the dimension model, now our new attributes should be filled and show us some values. And what we see here, we have the different, from 2 days, we have looked up the punctuality name and the rating, but let's filter here, maybe descending, if there are any null values, and there are null values. And why are there null values? Let's take one of these orders. And this is the kind of how you work with the Datavault Builder, that you develop, you test, and you improve your solution. So let's go back here. And let's filter for that. And what we see here, this order is still open. It was not delivered, means it is missing here the delay in days. So let's go in here and write the exception for that. So what we do is when this column is empty, so we can't look up anything, or we first say if it's not null, then take the lookup value, else take just the fixed value, which is for missing values. So let's go in here. And this is the value which is called, oh, I already filtered it here, so let's just remove this filter for time being. It's not delivered yet, so that's why. And we put that in here. Now, will that work? And we have an issue here because we have now a staging table, and the staging table was based on the assumption that it's an integer. But we are looking up here only text keys, so that's fine. In the business key, there can be as well a text, so that's perfectly fine. So just by fixing the business rule in here, and we can validate now that if we have some values in here like that, and we have, and yes, the days are missing, that's perfectly fine. So let's just start this job. And I'm loading now on the business vault because I didn't change anything on the raw vault data. And the cool thing is that now we created the process to creating this business vault load, and now as a user of and consumer of the data, I don't need to know how it's calculated. I can test the calculation, and the recipient doesn't need to know. He can just select from the model. So if we are going here, selecting it, our interface based on that is updated correctly. So we can just check for this data. We can go here and do here as well some descending, fill sort, and we see that we have a lot of orders that were not delivered yet. That's perfectly fine. We get the right text and everything. And we could improve that because there are as well some categories for errors and stuff like that. But for the time being, I would say I'm happy that we have created this kind of first calculation, then a lookup. So we split it in two smaller bits that we can test separately. We have filtered punctuality for the time being to include only the numeric values that our lookup works. We created the business vault load, we stored it in a model, and we have created our test output for the order line based on this. So will be able in the report already to filter for this kind of values. So let's go into the fact table. And now let's add here just the columns that are required. I need to look up in the specification what we need to have here. Give me 1 second. So we have here already quite some columns. What we need to have here additionally is from the punctuality element from this satellite. We need to have this column, and we need to name it in a special way. If you wonder where to get this is from the specification here in GitHub, where I'm reading here, where I have written my notes. So this is perfectly fine. These other columns are in there. So yes, that's perfect. So we have our first dimension ready. Let's have a look on how this looks like. Cool. And this is exactly what is required. So our first dimension for the order line is ready. Based on our model, based on our lookups. And in the next step, we will see what are the next bits that we need to here solve. And most probably I will go then for integrating the next source system into our data model. So after we have created everything for the Webshop system and we calculated the punctuality, let's go on and integrate the next source system. And for that we go here to the description and we say we are getting a new table with orders that are sold on site. So they are not delivered. They will be immediately delivered to the client. And It's just a denormalized table. So order and order position is in one line. We have a credit card information and stuff like that. So let's go on and let's stage this new system. So let's connect to it. We will be calling this system like this event where it's sold, called Roadshow, short ID. We pre-staged everything as well on the SQL Server. And let's see what the database name is here. We will have as well 3 days of data. Let's add that. Now we stage the table, and it's only one table, so it will be pretty simple. I just need to take the right schema. I select all the columns, no delta loading for now, and just add that. So the next thing we want to do is we start denormalizing it. And that's what I like about this Roadshow system. So we can go to the order line, and we can now try and see if the order number is unique, if they give really every order line its own ID, and we figure out, no, they don't. So let's have a look on what the issue is here. So if we look into one order, we see that we have different products, and this is in fact the key. We can check that against the data model, and we see, yes, the product is part of the key. Let's check it again. And now I will not automatically create a satellite because I know I want to normalize the data, so I don't need to select what is happening at which level. So let's add here satellite manually. Okay, let's take the Roadshow again. So what is directly dependent on the order line? All of this other stuff, it isn't. So let's create it. Now let's link it to the product. Oh, before I go on, let's do it properly. So let's remove the satellite, and let's remove the load, because I'm not 100% sure that this number ranges from the different source systems will not be overlapping. So I go in here and I change the Roadshow business key to something different. I will prefix it just to keep the data set from the Roadshow and the online shop distinct. The business promised me they have already distinct numbers, but should we trust them? I don't know. Maybe today, yes, but we don't know what happens in the future. So let's take this again. So we take the order ID and we take the product number, check this is unique, and here we can prefix it. So we prefix it with the Roadshow icon, Roadshow abbreviation. And now we can do this again. And we are not adding any conversions. It's coming already from a database, does have the right data type. So let's add the foreign key here to the product. This shouldn't be unique. Looks okay. Let's add the link. Now what else can we see here? There is a link to the customer, but in fact it's going through the order. So that's what is the freedom what we do here in modeling. So I add here an entry to the order. This will not be unique, but let's test that. We know that already. As well, this one we will be prefixing with the RS string. By the way, I didn't do that on purpose for the product, because the product should be integrated. These are the same products that are sold by two systems, so we want to have passive integration there. And that's why I didn't create it here a prefix for the product load. So if we go in here into the product hub, we see that everywhere we use just the product ID for all the loads. And here at the order level, we have as well some satellites. We're normalizing out here some of the information. What will that be? This will be the date when this happened, the transaction date where the stuff was bought. I'm not putting here the credit card information. I want to normalize that out as well into the credit card entity. So we can add the link here as well. If I didn't do that before, not sure. Oh, I did it already. So that's fine as well. I could as well highlight here a little bit what I already have done. Now let's go to the customer. And as well, the customers are the same customer. That's at least what the business tells us. So we will not prefix it. Customer ID, this shouldn't be unique. It's perfectly fine. And now there's specialty. We know directly here at the order what the credit card information was. So it's a little bit different than for the Roadshow system, where we extrapolated here the credit card from the customer table. But here, in that case, we will be adding here directly from this order line information. And just because I don't know anymore what was the order that I defined, I can look here. So it will be the credit card, it will be valid from, and the credit card company. And like this, we can passively integrate here from the two sources. And yes, this makes sense that different orders were paid by the same credit card. So that's fine. I don't want to create a satellite here anyways, except for the credit card information to split this. That's good. Because there might be credit cards coming from the Roadshow system that are not coming from the other one. So we can now add here a link. And the funny thing is we can as well add here a link from the credit card to the customer, because we have this information. Good. What else could we fill in? So just look through my list, which other stuff we are getting. So we filled the customer. Oh, we can fill the link to the club partner as well for this customers. This shouldn't be unique. That's fine. Let's add the upload. So we will be using this as source as well. Good, we have the order line and stuff like that. What I see here, we should as well give indication about the punctuality. And the funny thing is, let's go here to the business rules section and go to the punctuality. Let's create another output for all the values, because my base rule I already filtered for the non-integer values. Herein we will see a special record for this kind of Roadshow sales, and this indicates here ZZZ. It was sold directly at these Roadshows. There's no delivery date. We don't need to evaluate it, so that's irrelevant for our analysis. And that's cool. So we could do here what we have done here, and we could do here like a dummy value in here with the rule, but it would be too complex. I show you a different way. And we can directly, while staging, add here new columns and add here the default value. So let's edit that. Let's say we want to do a custom query. And in here, we just add a new column and call it Punctuality. Execute against the source, test it, we get the new column. Let's add it, and this will have just a fixed value. So by restaging this information, we can go in here, we can add here the link to Punctuality. And yes, it will be very boring, but it's relevant that we link the right value. We could do it as well virtually, so there are many different ways. But here, for the time being, that's perfectly fine. It's just another way that you see that you can as well create virtual interfaces to access your sources. And let's add here the link. And that's it. I think now we implemented everything that we can store from the Roadshow. Let's test it. So we have the link to the partner, to the product, to the customer. We additionally added here a link to the Punctuality, and as well we created an order. Good. So let's start loading. And let's load the first day. After it staged the data, we can start modifying it and prepare it for the second day of data. You see, I don't need to worry about how to create the jobs, how to run it, what in which order. Tool is creating everything. And because I created the SCD type 2 output for the customer, it already has added this load as well to the PID. It's updating the PID with the new data. So everything handled automatically. So let's load the third day. And we're good to go. So let's start that. But now we want to test this as well. And for testing it, let's go here and create our interface. Usually I would have tested much earlier if it would be the first time I'm implementing the data. And here we go at the order line, and that's the fact that we already created for the Webshop. And I will do now the same for the Roadshow. So let's go to the order line. Let's select it. We want to do it for the Roadshow, and we need a separate here interface because there will be different rules for harmonization and different field mappings. So I do here the function of fact, STD type 1, that's perfectly fine for the beginning. And it will show me already the columns that I used in the output. Maybe just, no, let's keep it like that. So what we see from the order line, we can already map the amount, the price, and the discount. So that's the same. So it can map that automatically. What we want to put in as well is the order. So later on, because it's a fact table, we want to take here in as well the business key for the order. We want to take here the business key for the Punctuality, or we could map the values, and this is how it's here done. So we take directly the link satellites, the satellite of the object. We see what can be mapped automatically. So let's map that. And then let's take as well the product. And from the product, I take the business key. Let's store that. And now we have created two different interfaces. How will they come together? There is a golden rule calculation engine directly built into the Datavault Builder. So if I go here to the object and I publish this rule, I can give it a priority. And because I don't want to combine the data, I know this data is distinct. Datavault Builder doesn't need to put any performance into trying to combine this kind of two values. I just put in here a -1. I don't want to combine the data. I just want to union it. Let's do this. -1. Let's save that. And we see here we used as well a column called Termintreue Bewertung and Bezeichnung. So I want to go back and add this here. Just thinking what exactly, if we want to do this in German or if we should do it in English, but it looks like the requirement is here at the level of German. So let's do it German. Let's combine these two values. By using the same column names in the different interfaces, the tool will know how exactly it needs to combine the data. So if we go down to the business rules, we have now in both of them these columns, and they will be automatically combined into one output. So by publishing these two systems, we can go now to the data viewer, look at the interface, and now from both systems, we can have a look like on the product, and we can maybe sum the amount. And after a few seconds, we should get here the answer from the database. We can do here a tree map. And we see right now that we have some null values. So where are the null values to the product coming from? Let's investigate that. Let's go to the business rules section. Let's have a look first here at the Webshop data. And the problem is that I have added the business key for the product already to the Roadshow, but I didn't add it to the Webshop. That's a small thing to correct. It's now validating all the rules based on this if they're still valid. So let's refresh that. And now we should get a new distribution of the values. And that's it. We see that product 1 is our most sold product. And this is now data from both systems. Can we validate that? Yes, we can, because we have certain values like the rating of the punctuality, which is only available in one system and not in the other, which is not applicable. And we see here that most of them, like sold in the roadshows, it's irrelevant. No. Yeah. And you see here, it's sold on the roadshows, it's irrelevant. And then we have the other ones, but maybe this here is better at the bar chart, or maybe as a table. And we get the figures, we can sort here by totals and see the values, how this is distributed. Good. So this concludes the part where we have integrated the two source systems. We have passive integration in the hubs. We have created now our fact table that is integrating both of the stuff. So the last thing that we now need to add is to create all the interfaces for fact and dimensions as we need them. Create our first test report, and we are done. So let's go now to the report part. And here we have some requirements in the Willibald case, and we want to see the quantity and revenue by product. We want to see quantity and revenue, but not yet fully delivered. We want to see the deviation by category from the functionality table. And we can assume that orders without a customer are from the Roadshow, and we want to have a dummy in there. So let's go step by step how to solve that. And the first thing I'll look at is the order line, which will be our primary fact. And in here we have already the hub order line, the order, and the product for the Roadshow. And we have the same already prepared here for the Webshop. And here I have too many columns. And I'm not editing directly here the unaltered rule set. I'm going here back and let's modify here the order line here for the Roadshow. And what I will do is here I will remove some of the columns before I do that, just to speed up things and that nobody accesses it while I'm working here. I unpublish that. Wouldn't be really necessary, but just everybody knows that I'm just working right on that. Good. So let's go in here, and what I want to remove is the days from and to. That was from my testing, as well the rating. I want to take this in a separate dimension. So what we have here is the amount, the price, and the discount, and we will need to calculate that. And additionally, already, because I see here that we will have like the product. So I go in here, I have the business key of the product. I want to go as well here to functionality and include that. So I don't need to modify it later. Additionally, we want to have the client. And here I'm in the Roadshow, and the Roadshow link to the client is not really good, but through the credit card, we can find sometimes clients from the Webshop. So I want to include this here. And yes, I could evaluate both paths and then do some logic, in which case which wins. But for the time being, I just want to reduce it to the minimum. So this is what I do here on the Roadshow side. And you will see already why we split that between the source systems, because I will do not exactly the same at the Webshop side. Because at the Webshop side, I can go directly to functionality as in the other interface. And additionally, I can now go through the order to the customer directly. I don't go through the credit cards. I'm taking a shorter path because here in the Webshop we have already the customer in here. So let's add this. Let's store that. Let's check if we have anything wrong in here. Discount Bezeichnung. So these two columns I want to remove. That's the deliver date and wish date. Yes, that's fine, because this is specific to the Webshop. We don't have this in the Roadshow stuff because it's always ordered and sold on the same day. And this means that we now should get already our first fact table. But we need to add as well a business rule. And the business rule will be the calculation of the discount. So we have here the amount and everything. And I will output that as it is. And I will create here additional business rule for calculating now the total order line price. Let's just check if this makes any sense, what I clicked here. So it's looking up all the links and compiling if this makes any sense. In fact, I can already publish that. I don't want to change that anymore. And I add here another, and it's the sales order line total. And here I remove all the columns that I don't need. And here we need to put in our small calculation. And where do I get this calculation from that I'm applying here? This calculation is coming from here, the amount multiplied by the price and by the discount. So let's do that. Here, let's say we have the amount multiplied by the price multiplied by 1 minus the discount. And the discount is in percent, so we need to divide it by 100, and this gives a sales order line total. And I have put now this special rule into a separate thing, so I can now do the calculation and testing separately, deployment will be separately, maintenance will be separately, so I don't need to think about collisions later. And if I store that, we can preview if this makes any sense. We can validate that rule. And now I can just store here, include an access layer, and it will join it together with the other stuff. Now let's do the same stuff on the sales on the Webshop side. And usually I would find different columns there. This is here now a little bit synthetic data, so we find a lot of stuff here which is already named the same, or we could have harmonized it here at the dimensional model level. For sure, we can now add here now a new rule. I call it as well sales order line total. Again, we are lucky. This is exactly the same rule that we are adding here. And if you see now, we will have the same amounts that we need in fully delivered or not yet fully delivered. And the good thing is we have calculated this before. This was in the 5-minute bit that I didn't record it, but here in punctuality calculation, we have already this rule. If this is still open, the contract, and we can just publish now this rule, and we will have these columns that we calculated available as well in there. Now the funny thing is that this doesn't exist for the Roadshow. So what we do here is we add a new rule. And this one will be pretty simple. We just say, no, it was fully delivered if it was sold, and it was not late, and stuff like that. The question is if we really should calculate the number of days it was late, because null is the better value in fact, but it depends really on the business that you want to have. So is the contract still open? No, it isn't. Was it fully delivered? Yes. Now even we have put the logic into smaller blocks. We should see that now in our report at once. So what we do now is we go over to Power BI, and I'm not really a Power BI user. I'm just using it here for visualization of what we have done, and I try to find my way around, so please show some goodwill if I click somewhere on the wrong thing. But what I want to show you here is that we don't need to write any big logic. We just take the table that we want to import. We can preview it because it's now coming from the database. It's integrated from 2 different systems. We have already added the business rule calculations in there. And let's see what we see here. So we have the hub, we have the calculation of the total value, we see if the contract is open or if it was completely fully delivered. We can see the order, the product, functionality, and some of them don't apply because they were like from the Roadshow. The customers in here. And we see here, I didn't calculate it for some of them now the delay because it's not applicable. So these are not applicable. I didn't fill it because if it would be 0, it would maybe show me wrong statistics. Even honestly, it was delivered on the day the customer wished it, so it could be as well now. It depends on your business use case. So let's add this. And I'm not adding only that because I already prepared the product. So let's have a look at the product. The product already contains as well, because we tested our hierarchical linked categories, we can add this as well. We could add here as well the order, but I don't see the point in that currently. So let's add the first two things and check how it looks like. The product was added, so we can test it now. I already prepared here a report, but just that we can do it from scratch. Let's add maybe some stacked column chart. And we can now take from the product maybe the product category name. And we take here sales order total. And maybe let's take the product category name in here. So, and maybe we can group that now by if it was completely delivered or not. So let's have a look at what we have in here. Completely delivered or open. So let's say completely delivered. And we see that most of them were already completely delivered. So we could filter here for not yet delivered, delivered. So this works out of the box. And instead of taking here the product category name, we could take here the product super category name. And it works out. And here instead of, we would take maybe the product category name as legend and split it up by that. And this looks already very promising. But we can't link here yet to Punctuality. Why not? Because we haven't published it yet. So let's go back here. And the good thing is I already created here an interface. I didn't just publish it for Punctuality. And we haven't yet published anything for the customer. So let's have a look. This here is a STD type 2 interface. I don't want to use that. I go just in here and I add here something new, customer. And we take it as is. Now we select here the name and everything, but if I did it already in STD type 2, it already proposes me which columns I could choose here. So I just rely on that and say, yeah, that looks already very good. So let's take the ones. I could still extend it, browse through the model, and see we have here two relations to the club partner because one is represented by the customer and this customer belongs to the club partner, stuff like that. So let's go now to the business rules section, publish that one. And we can go back to Power BI. And here we add some more tables. So the punctuality and the customer as is. Let's add that. And the cool thing is that if we set the business key correctly, if we did the selection correctly, Power BI is automatically putting everything here into the data model, composing it, and we just need to check if there is no error. So here, that's on the business key customer to the customer, and this here is based on the business key for punctuality. That looks already good. So we get slowly here into a very nice dimensional model without writing one line of code as well. Here in Power BI, we just select the tables that we want to have, and we can go back and start switching. So we go back here and we take here now maybe from the customer, we take the partner. We see here already how it's distributed, and now we see this error or problem that they told us. If there is no partner or from the Roadshow, so we should add here a Roadshow dummy into it, and we can add that. By the way, what I showed here is the legend of the partner of the customer. We didn't evaluate it where it was sold. That would be a different information, but here, because we have no client or no customer, we have here blank. So we need to add here now this new information to it. So let's go back to the Datavault Builder, because we have found that in testing. And in the order line here for the Roadshow, we give it a priority rule. We say usually take the values that you find in the Datavault, but in the case that you don't find a value in the raw vault, now let's take a link to a dummy customer. Let's do that. And we call this just with natural key of Roadshow. Let's hope that no client is called Roadshow. And we do just the dummy now as requested here. For the client, we don't do it for any other value right now. And let's store that, let's test it. So let's preview the results, publish it, and we give it the priority of 2. So we say, if really there is no real value, use the Roadshow value. That's what they requested here. That we need to insert this dummy customer. I'm solving it exactly as required. And when doing that, let's inject here as well the dummy. So we could add here as many dummies as we want if there are different kind of errors that we want to cover. And we can do here a search and replace. And we search for BO dot and we replace it with Roadshow. This will not make any sense for certain of the values. So let's take the credit card out here. Email, that's fine. Phone, birthday, this date. Something like that. Let's test it. And now we go back to Power BI. Let's refresh the data. And the interesting point is why we still don't see the record. Point is, there is the Roadshow thingy. What we see, but as well, is that if we go into the blank category, that we have certain customers, and it looks like customer 234 has maybe no partner ID. Let's check for that. So let's go into the customer. So it's 234. Let's check. And it's a fact. So it could be he doesn't have a partner ID, but we go back to Power BI. Let's check if he got the name. And he got the name. I see that in Datavault Builder, so that's fine. So in fact, that's really that this partner ID here is so what we want to do is here to group it. So it could be useful to say that we write here a rule and say if a customer has no Vereinspartner ID, we want to set it to unknown, so we see that we've really thought about that. So let's go in here in the rules. Oh, it will not work. So let's go back here to Power BI, reload the data, and this is exactly this interactive thing that we do, that we look at the data, we look at the reports, we see maybe potential problems, and we can fix it, and it's very simple to fix that in the Datavault Builder, directly publish again, and we can look at the results. And this looks much nicer with no partner. So we have now solved all these requirements that we have here. We can go here into functionality. We can as well look on, instead of the partner ID, what kind of delays do we have, stuff like that. So we really have now a small universe now that we can report on based on the model, and we don't need to know where the data is coming from which source system we have. The data lineage information for that. But in the report itself, we don't need to worry. We just go if we need some new data. We look at the data model. Can go here to the bookmark section to see the picture again that we had. We can select from all of this, create our facts and dimensions, and I created them only as of now right now, but as we have seen before in the testing, we can as well access this data with as it was with SCD type 2. So if you look at the customer, it will not only show us the current value, but as well the history. So we can decide when we're creating the reports, if we want to see the history of from which time to which time the stuff was valid, or if we just want to go the latest value per business key. In the background, the operations jobs were created, so we can run the Roadshow or the Webshop stuff directly. So either by clicking it here or through the REST API or schedule it in here. You can get the documentation, regenerate it, and it generates really from what is there in the database. The documentation again, all this information is available as well as API information and views in the database, and we can use deployment to deploy it to our next environment, which I will show in the next section. So the last thing we want to look at is the deployment part, and here we have several ways of deploying stuff. One is to compare two different environments, so we could connect here to a remote environment and compare a local to a target environment to make it very simple. I compare it now against a dummy environment called empty environment. So like our test environment is completely empty. And this is the simplified way. So this is if I'm working in a smaller team and I want to just compare here directly the results of my local work in development to test or test against production. I can go and at the logical level see all the differences, and I can select here like one of the rules that I want to deploy, and it does all the dependency checks. I can include that, and I can deploy the scripts directly if it would be a real environment, or I can write the scripts, so I can download it, I can hand over it to Release Manager. That's for smaller companies. For bigger companies, by the way, we could select here everything. Let's write a deployment script. It doesn't take longer. Just calculates all the dependency, all the orders, and it gives me a deployment package to deploy against my target. Now here, I can go as well and say, I don't want to deploy directly. I want to use the Git flow-based process, so I can press the button and it downloads me the full description of everything in one combined file that I can check into Git. And in fact, it's not one file. This is a collection of many small files. And this goes then in different folders, in different files, into Git, and you can do a full Git flow-based process. I'm not showing here the details. If you want to know more, you can book one of our demonstrations, and we can go really in your case that is there, just that you know that this is part of everything as well as operations, that we can go in here and directly schedule the calls on our system. It will be everything logged, so it's really complete. We are production ready, we can deploy. So really the use case is covered. The next step would be to go to the business user, talk to them, and see if these are the results they're expecting, do some testing, get feedback, write some stories down, what needs to be changed. So it's not the final version. We are working agile, so this is what we have done based on the initial definition of requirements. And from now on, we will take it up with the business users and go story by story. But you see already that now within a little bit more than 2.5 hours, we managed to create the integration of two different systems. We have created some rules, we have hierarchical rules, we have resolved some lookups, and we have a really production-ready installation. We have tested our data, we have created our first reports, and now we can go into further testing with the business user and get some feedback if there are any problems, or if there are any problems in the data that we need to fix and solve. Thank you a lot for your attention. Please be aware, this is not like a demo presentation. This is really creating a use case. So we have left in all the bits and pieces that went wrong. as well. So if if I saw that there are some null values, we didn't cut out the part, but we went back, fixed that you really see as well how the working is with it. So I understand it can be a little bit challenging to watch somebody work 2.5 hours and see really what he's doing. But I hope that's a really fair impression of how the Datavault Builder works and how the work for you would look like. Thank you.